Okay, what we're going to do now is we're going to measure the overfire draft on an oil-fired unit. This happens to be a furnace. It's a Category 1 venting system, but most of your furnaces, gas or oil, they're going to be firing in a negative combustion area, mainly for safety. If you have a cracked heat exchanger, you're not going to have carbon monoxide going out. You'll have air coming in, which we'll talk about using combustion analyzers to determine cracks later on. So what we're going to do is get the overfire draft. We have to make sure our overfire draft is around negative 0.02. That'll be right on. An overfire draft should be measured in the beginning when you fire the unit up. You want to have a negative environment at fire. If not, when I fire this up, if it's not negative over fire, you're going to have a pulsating, rumbling, soot. It can really rumble, make a lot of noise, and you'll end up with soot coming out and soot getting into your airstream. So we have this fired up. We're going to use the Insight. This is the Insight combustion analyzer. We use it for steady state efficiency. It's also combustion gas analyzers, what I should call it. We're going to go to our menu. We're going to go to pressure, and we're going pressure. Now I have, it's electronic manometer now. So I'm using a manometer. I'm going to be measuring in inches of water column. So I'm going to want to zero it. And you're supposed to disconnect the hose and reconnect it, but it's still giving me zero. Again, we're going to read inches of water column. We're looking for a negative 0.02 would be ideal. Too much overfire draft, we're pulling where it's inefficient. Not enough overfire draft, we're going to have that rumbling, that pulsating going on, that soot creation that we don't want. So I'm going to put my analyzer right here. I'm going to go right over the fire. We have a hole drilled. It's a fairly large hole in this unit for some reason. And I'm going to pull the plug out. Probably pretty hot. It's like somebody got carried away with the drill. But I'm going to then put it over the fire and measure my draft. Now I'm reading, you can see I'm reading a negative 0.03. Negative 0.03. Which was a little bit too much draft. Now we're down to a negative 0.02. So that would be a decent draft right there, negative 0.01. It's moving around a little bit. Really sensitive. But I'm right over the fire. In this case, I'm going to have to kind of watch its movement, try to average out what we see most. It can be difficult in some cases. The reason why this one's so difficult is because we're using a draft inducer on the other side, and we're getting some air coming in from other furnaces and stuff, and it's kind of making it erratic. Most of the time, residential situation, it's going to be pretty consistent. There, we're at negative 0.03. The way we adjust the overfire to negative 0.02, I'm going to need to use my draft, barometric draft regulator, which you can see right here is my barometric draft regulator. It's in the flue pipe, and there's a weight on the side. It's barometric. What's going to happen is this is going to bring dilution air from inside the basement, and what that's going to do is if I start to get more draft, it's going to start to pull more air out of the basement rather than pull it through the appliance. So once I set this draft up with the barometric draft regulator, get my overfire draft set up, it should stay the same. So again, the barometric draft regulator with this weight, we close that, we get more overfire. So once we get that set up, my overfire draft down here, that will stay consistent even when my flue system heats up. So again, that's measuring the overfire draft. And this should be done in the beginning when you first fire up the unit. Overfire drafts are going to be, it's a lot easier to get a negative 0.02 in the winter time. So I tell people in the fall, if you get a negative 0.01 or spring negative 0.01, you're probably going to be okay. But if you're getting a negative 0.01 and you can't get enough draft, you're probably not going to be good in the spring and the fall when you need a little bit of heat, because it's harder to get draft in the warmer when it's warmer out than when it's colder out. So again, negative 0.02 is what we want. In the fall or the spring, you can get away with a negative 0.01, but if you're only getting a negative 0.01 in the winter, then that can be a problem. So again, negative 0.02 is what we want. We'll settle for a negative 0.01 in the fall or the spring, because that's our worst case, but negative 0.02 is the ideal overfire draft.